Alright guys, I just found out something really cool with the PASCO weather sensor that I have to share with you. So I set up the weather sensor on the patio of my backyard on July 13th around 11:59 p.m. and I left it for a day to the next day, July 14th, 11:59 p.m. Just want to see what the day's weather looks like, right? And it's almost as I expected, except for one thing. Let me show you. So this is the temperature graph, and you can see from July 13, 11 p.m., the temperature goes down until around 5 o'clock, and then the temperatures where the sun arises, and then it starts to go up during the day, and it peaks at around 4:30ish p.m. and then goes back down again in the evening. So this looks fine, right? Looks actually pretty good. It's a sine graph which shows the fluctuation of temperature during day and night, except for one thing. If you look at this is around 8 o'clock in the morning, there's an unusual peak. Can you see that? So it should really be a smooth transition. So that will make it a really nice sine graph. It should look something like this, right? But there's an unusual peak, which is really strange, and I was trying to understand why. And then I remembered, so for the PASCO weather sensor, if you want to measure correct temperature and relative humidity, you have to make sure it's not directly exposed to the sun, right? And that's why I left it in my backyard in a sheltered place. As you can see from the picture, it's under a roof, protected from the fences around it. But there might be some gaps that the sunlight may be going through directly and just hit on the weather sensor directly. That'll cause this anomaly. Okay, so to investigate this, let's first take a look at the Illuminance and UV index graph. So I'm expecting at this time there's gonna be an anomaly in Illuminance and UV index as well, because I'm suspecting at this time the sunlight find a gap to go through to get the weather sensor. Okay, let's see that. Let me pull out the Illuminance. Illuminance is basically how much direct light you get on a surface. There we go. Exactly as we expected. You see, Illuminance is normally just very low, right? Because it's kept in a sheltered place on purpose. And you see this strange peak at around, okay, let me show you. This is 7:57. I don't know if you can see this. Let me zoom in. Okay, 7:57 a.m. right? And like a 7:55 around that time, it's also part of the peak, right? So around 8 o'clock, something like that. And you see this strange peak, and you see that not only on the temperature graph and also on the Illuminance graph, which indicates there's direct sunlight. And we can also pull out the UV index. Let me see, UV index. There we go. UV index is the orange one. and the purple one is the Illuminance, and you can see they both peak at the same time as well as the temperature. So 3 of them all have anomaly at this time, around 7:50 to 8 o'clock. You see this 7:53, and then all the way to about 8 o'clock. So what I did to investigate this is I actually got up early in the morning the next day on July 15th at around 8 o'clock and observed the sun. This is what I got. Alright, so this is a screenshot of the time when I took this video. I'm going to show you a video in a second. So I took the video at 7:54 a.m., which is the time I'm expecting to see direct sunlight on the weather sensor. And there we go. Alright, can you see the sun is directly behind the weather sensor at this time? And if I move the camera a little bit, right, the sun comes out, which means it's directly behind the weather sensor, and the sunlight is shining directly on the weather sensor. And this is the temperature chip, right? The temperature relative humidity sensor, which is not supposed to be exposed directly to the sunlight, because it's supposed to be measuring the air temperature, right? And if you're exposing it directly to the sunlight, it's also heated by visible lights and infrared radiation directly from the sunlight, which will make your temperature peak a lot higher than the actual air temperature. It's supposed to be measuring. Okay, and I moved around the camera. You can see it's in a pretty well sheltered place. There's the roof, and there's the fence on the side, and there's building in front, and more buildings, and the wall, and the pillar, the fence over here, right? And there's also a tree. So the only gap the sun can come through is actually from here. The rest of the space, I think, is well protected, well sheltered from the sun, except for this part. And the time the sun arrives in here is 7:55-ish to 8 o'clock. Okay, so, and after that, there's the tree that's going to be protecting the weather sensor from the sun. So this is about the only gap the sunlight can come through. And the time the sun is there matches our graph, which is around 7:55 to 8-ish, 7:50 to 8-ish. Right? So that's something really cool I find out with the PASCO weather sensor. It's really our result really actually tells you what happens in reality. You just need to do a little bit of analysis. Okay, if you see an anomaly on the graph, and that normally tells you something, and if you investigate why, you may be able to find the reason, and this would be one example.